The morning of February 21st, 1945, Staff Sergeant Richard Chambers sat in the driver's seat of a 30-ton Sherman tank, watching black volcanic sand kick up behind the infantry moving ahead of him. 2 days into the battle for Iwo Jima, and already the math wasn't working. Chambers commanded one of 8 M4A3 Sherman tanks that looked like every other Sherman rolling across that nightmare island, except for one critical difference. Where a 75mm cannon should have been, his tank carried something the Japanese had never encountered before. A flamethrower with a 150-yard range, fed by 300 gallons of napalm-thickened gasoline. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Marines ahead of him had stopped advancing. Chambers could see why. A cave entrance, maybe 4 feet high and 6 feet wide, cut into the rocky slope about 80 yards uphill. Intelligence said the Japanese had built 11 miles of interconnected tunnels under this 8-square-mile island, some of them large enough to hide 300 men. From where Chambers sat, he couldn't see inside the cave, but he could see the bodies of 3 Marines who'd tried to get close enough with satchel charges. The Japanese defenders inside that cave had machine guns, grenades, and time. They could wait. The Marines couldn't. Chambers's radio crackled. A Marine captain, voice tight with frustration, requested support. The standard 75mm guns on regular Shermans could pound that hillside all day and accomplish exactly nothing. High explosive shells either bounced off the reinforced concrete or penetrated a few feet before detonating uselessly against solid rock. Naval artillery had been hammering Iwo Jima for months before the invasion. The island looked like the surface of the moon, cratered and torn. But, underground, the Japanese fortifications remained virtually untouched. The problem facing American forces in early 1945 wasn't new. It was ancient, actually. How do you kill an enemy who won't come out and fight? The Japanese had learned brutal lessons from earlier island battles at Tarawa and Saipan, where banzai charges and beach defences had been slaughtered by overwhelming American firepower. Their new doctrine, implemented with terrifying effectiveness on Iwo Jima, emphasized defense in depth from underground positions. Every cave had multiple entrances, every tunnel connected to 5 others. Kill the defenders in one room, and fire would erupt from positions 50 yards away, accessed through passages American forces couldn't see or target. Lieutenant General Tadamichi Kuribayashi, commanding the Japanese defense of Iwo Jima, had spent nearly a year transforming the island into a fortress. He understood something that previous Japanese commanders had missed. America's industrial superiority and firepower dominance meant that any above-ground defense would be annihilated. The solution was to go underground, deep enough that bombs couldn't reach, interconnected enough that destroying one position accomplished nothing. By February 19th, when the first Marines hit the beaches, Kuribayashi commanded 21,000 troops hidden in positions that naval bombardment and airstrikes had barely touched. The caves varied dramatically in size and sophistication. Some were natural volcanic formations, expanded and reinforced. Others were engineered from scratch by mining specialists sent from Japan specifically for this purpose. The smallest held 3 men with a machine gun. The largest were multi-story complexes with ammunition storage, command centers, and living quarters built 30 to 40 feet underground. Every major cave had been stocked with food, water, and ammunition sufficient for months of resistance. 4-foot-thick, reinforced concrete pillboxes protected the entrances. The caves were positioned so that American artillery couldn't hit them directly. Fire into the entrance from the front, and the shell would ricochet off the angled concrete. Try to flank them, and you'd expose yourself to interlocking fields of fire from neighboring positions. American commanders had encountered cave defenses before, but nothing on this scale. On Peleliu, in September 1944, the 1st Marine Division had taken 33% casualties, fighting similar underground positions over 2 months. The standard solution was miserable and slow. Infantry would advance under covering fire, get as close as possible, and then individual Marines with backpack-mounted flamethrowers would try to get within 20 to 45 yards of the cave entrance. The M2-2 flamethrower, the best portable model America produced during the war, held 4.5 gallons of fuel and could fire for about 7 to 9 seconds before running dry. Its maximum effective range was 45 yards. Those statistics translated into a brutal tactical reality. The flamethrower operator, carrying 70 pounds of fuel and compressed nitrogen on his back, had to move across open ground under fire to get within range. The weapon made a sharp hissing sound when activated, immediately drawing concentrated enemy fire. The bright orange flames created a massive visual signature, marking the operator's position for every Japanese soldier in the area. On Iwo Jima, Marine after-action reports noted that flamethrower operators suffered catastrophically high casualty rates. The Japanese concentrated everything they had: machine guns, mortars, rifle fire on anyone carrying a flamethrower. Some units reported that the life expectancy of a flamethrower operator in combat was approximately 4 minutes. Even when the operator survived long enough to engage a target, the results were often disappointing. The portable flamethrower's stream would reach the cave entrance, splash against rock and concrete, but often fail to penetrate deep enough to actually affect defenders positioned farther back in the tunnel system. The Japanese would retreat deeper into the cave, wait for the flames to subside, then return to their fighting positions and resume firing. Clearing a single well-defended cave could take hours and cost dozens of casualties. This was the tactical nightmare that Staff Sergeant Chambers had been training to solve, though he didn't know it yet when his tank was still being assembled in a Navy Seabee workshop in Hawaii 4 months earlier. The story of how that flamethrower ended up in Chambers's tank begins not on a Pacific island, but in a basement laboratory at Harvard University on Valentine's Day, 1942. Professor Louis Fieser, a 43-year-old organic chemist, stood in the basement of the Converse Chemistry Laboratory on Oxford Street in Cambridge, Massachusetts, working on a problem that seemed purely theoretical. The United States had been at war for just over 2 months, and the Chemical Warfare Service had approached Harvard with an urgent request. They needed a better incendiary compound. The existing flamethrower fuel, gasoline mixed with natural rubber to create a gel, worked adequately in theory, but faced serious practical limitations. Natural rubber was desperately scarce. The Japanese had captured the rubber plantations in Malaya, Indonesia, Vietnam, and Thailand, controlling over 90% of the world's natural rubber supply. What little rubber remained available in America was needed for vehicle tires, tank tracks, gaskets, medical supplies, everything that kept a modern military functioning. Using it for flamethrowers was wasteful and unsustainable. Fieser and his team, including his colleague E.B. Hirschberg, tested dozens of chemical combinations. They needed a thickening agent that would turn gasoline into a sticky gel without requiring rubber. The solution came from an unexpected source. Fieser discovered that mixing gasoline with aluminum salts of naphthenic acid, derived from crude oil, and palmitic acid, extracted from coconut oil, created exactly the properties they needed. The mixture gelled perfectly, stuck to surfaces when ignited, and burned at extremely high temperatures for extended periods. Fieser named it Napalm, combining Na from naphthenic and palm from palmitic. On July 4, 1942, Fieser conducted the first public test on the Harvard College soccer field between the business school and the football stadium. He activated 45 pounds of the substance. The explosion reached 2,100 degrees Fahrenheit, burning with an intensity that shocked everyone present. Conventional gasoline flames would burn out in seconds. Napalm burned for minutes, sticking to whatever it touched, impossible to extinguish with water. The heat was so intense it would consume oxygen from the surrounding air, causing suffocation even in spaces the flames themselves couldn't reach. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The military applications were immediately obvious, though Fieser himself later expressed ambivalence about what he'd created. In 1967, He told a journalist, "I couldn't foresee that this stuff was going to be used against babies and Buddhists. The person who makes a rifle isn't responsible if it is used to shoot the president." But in 1942, with the war's outcome uncertain and American forces desperate for any advantage, ethical considerations took a back seat to tactical necessity. Napalm first saw combat use on December 15, 1943, when American troops in Sicily used napalm-fueled flamethrowers to burn down a wheat field where German forces were hiding. The improvement over standard gasoline was dramatic. The thickened fuel traveled farther, stuck to targets, and created fires that couldn't be easily extinguished. By 1944, napalm had become standard issue for American flamethrower units in both the European and Pacific theaters. But portable flamethrowers, even those using napalm, still suffered from fundamental limitations: range, fuel capacity, operator vulnerability. The answer seemed obvious. Put the flamethrower on a vehicle. Armor would protect the crew. A larger fuel tank would extend operational time. A more powerful propulsion system could potentially increase range dramatically. The problem was implementation. Early attempts at vehicle-mounted flamethrowers had been crude field modifications, replacing hull-mounted machine guns with flame projectors. These worked marginally better than portable units, but the range was still limited to around 60 feet, barely an improvement. The breakthrough came from an unexpected source. Not from Army Ordnance engineers at Aberdeen Proving Ground, not from tank designers in Detroit, but from Navy Seabees in Hawaii. Construction battalions, nicknamed Seabees, were combat engineers responsible for building airfields, roads, and port facilities under fire. They were selected for mechanical aptitude, welding skills, and creative problem-solving. They were, by design, men who could improvise solutions with whatever materials were available. In April 1944, the Army Chemical Warfare Service's Pacific Command, under Colonel Unmucht, assembled a secret unit at Schofield Barracks in Hawaii. The goal was ambitious: design and build a vehicle-mounted flamethrower system powerful enough to reach deep into Japanese cave systems. The project pulled personnel from the 43rd Chemical Laboratory Company, combat engineers from the 5th Marine Tank Battalion, and 25 Seabees from the 117th Naval Construction Battalion. The Seabees looked at the Army's initial design and concluded it was over-engineered. Too complex, too many moving parts, too difficult to maintain under combat conditions. They started from scratch, combining elements from 3 different flamethrower systems: the Ronson commercial model, the Navy's experimental Mark I, and lessons learned from portable units already in use. The result was the CBH-1 flamethrower, specifically designed to be mounted in a M4A3 Sherman tank, replacing the main 75mm gun. The engineering challenges were substantial. The flamethrower system needed 300 gallons of fuel storage, which required completely redesigning the Sherman's internal layout. The fuel tanks had to be armored to prevent catastrophic explosions if the tank took fire. The propulsion system needed nitrogen pressurization powerful enough to project napalm 150 yards. That's 5 times the range of a portable flamethrower, and far enough to engage cave entrances from positions that Japanese small arms couldn't reach effectively. Each installation required 150 pounds of welding rod and 1,100 electrical connections. Cost per tank ranged between $20,000 and $25,000 in 1944 money, equivalent to roughly $400,000 today. The timeline was brutal. By September 1944, Colonel Unmucht's unit had modified 8 tanks for Operation Detachment, the code name for the Iwo Jima invasion. The tanks were designated M4A3R3, though different documents used different nomenclature. Army Chemical Corps records called them POACWSH-1, Pacific Ocean Area Chemical Warfare Section Hawaii. Marine observers at Iwo Jima referred to them as CB Mark I or just Mark I. Marines on the front lines simplified it further, calling them Zippo tanks after the cigarette lighter brand, or Satan's. The official Marine Corps designation was M4A3R3. The Japanese, in documents recovered after the battle, called them M1 tanks, possibly due to a mistranslation of MH1. Whatever the designation, the tanks looked identical to standard Shermans from a distance. The flamethrower nozzle was disguised inside a 75mm gun tube. This was deliberate. Japanese troops had learned to prioritize flamethrower operators as high-value targets. If the flamethrower tank was obviously different from standard Shermans, it would draw concentrated fire immediately. The disguise gave the tank precious seconds of operational advantage before Japanese defenders realized what they were facing. The tanks retained their bow-mounted machine gun and the commander's 50 caliber machine gun on the turret. The armor was standard Sherman, 51mm of frontal hull plating, enough to stop small arms and some anti-tank weapons, but vulnerable to dedicated anti-tank guns. Maximum speed was 30 miles per hour on roads, dropping to maybe 15 across rough terrain. The crew consisted of 4 men, a driver, bow gunner, commander, and flamethrower operator. Training for these crews was minimal. The tanks weren't even completed until late January 1945. Most of the crews got maybe 2 weeks of familiarization before being loaded onto transports heading for Iwo Jima. They practiced firing the flamethrowers at target ranges in Hawaii, learning the weapon's reach and behavior, but nobody had combat experience with vehicle-mounted napalm projectors at this scale. The doctrine was being invented as they went. The 8 tanks arrived at Iwo Jima on D-Day, February 19, 1945, landing with the assault waves. But they weren't used immediately. Marine commanders were cautious. These were untested weapons on a battlefield where every mistake cost lives. The tanks sat idle through the first day of combat, while planners decided how to employ them. On D+2, February 21st, someone gave the order to try them. That's when Staff Sergeant Richard Chambers got his call. A Marine Infantry company was stalled in front of a cave complex on the western slopes. Artillery hadn't worked. Infantry assaults had failed. Portable flamethrowers couldn't get close enough. Send in the Zippo. Chambers advanced his tank uphill, tracks grinding through volcanic sand, keeping the hull angled to minimize exposure to potential anti-tank fire. The cave entrance was 80 yards ahead. He could see Marines hunkered behind rocks and debris, watching his approach. Japanese fire was sporadic but accurate enough to discourage movement. Chambers stopped the tank at approximately 120 yards from the target. This was the moment that would define the weapon's effectiveness or failure. The flamethrower operator, positioned in the turret, aimed the disguised nozzle at the cave entrance, checked the nitrogen pressure gauge to confirm they had full propulsion power, and activated the ignition system. The weapon used a spark plug mounted inside the nozzle to ignite the napalm stream as it exited. Get the timing wrong, and you'd spray unignited fuel, which was worse than useless. The operator squeezed the trigger. What happened next was something no one on that battlefield had ever witnessed. A stream of burning napalm erupted from the tank, arcing across 120 yards of open ground in roughly 2 seconds. The flame wasn't like portable flamethrowers, which produced a fairly dispersed spray. This was a concentrated jet of fire, pressurized by nitrogen to maintain cohesion across distance. It struck the cave entrance and splashed into the opening, the liquid flames sticking to rock, concrete, and anything else they touched. The napalm mixture burned at 2,100 degrees Fahrenheit. At that temperature, rock itself begins to glow. The flames didn't just illuminate the cave entrance. They consumed the oxygen inside, creating a pressure wave that pushed deeper into the tunnel system. Japanese soldiers positioned 30 or 40 yards inside the cave, far beyond where portable flamethrower flames could reach, suddenly found themselves in a rapidly deoxygenating environment, filling with superheated gases and carbon monoxide. The biological effect was immediate and catastrophic. The tank's fuel capacity allowed sustained firing. Chambers's operator held the trigger for approximately 8 seconds, expending roughly 40 gallons of napalm. Then he released, waited 3 seconds for the nozzle to cool slightly to prevent ignition system burnout, and fired again. Another 8-second burst, 40 more gallons. The Marines watching from cover later described it as being like watching someone use a garden hose, except the water was fire and the hose could reach across a football field. After the second burst, no more fire came from the cave. The Marines advanced cautiously, expecting resistance. They found 17 Japanese soldiers dead inside, most from suffocation and carbon monoxide poisoning rather than burns. The cave system extended another 100 yards underground, but the heat and oxygen depletion had penetrated far enough that defenders deeper in the tunnels had either evacuated through alternate exits or succumbed to the conditions. Word spread through the Marine divisions within hours. The flame tanks worked, better than worked. They were devastating. Company commanders who'd been planning multi-day assaults on fortified positions suddenly had a tool that could clear objectives in minutes instead of days. By the third day of the battle, Marine units were refusing to advance on cave systems without flame tank support. After-action reports describe Marines holding positions under fire, waiting for one of the 8 flame tanks to become available rather than attempting assault with conventional weapons. The tactical shift was profound. Japanese defenders on Iwo Jima had been confident that their underground fortifications made them essentially immune to American firepower. Naval bombardment, airstrikes, tank guns, artillery, none of it could effectively neutralize positions buried under 30 feet of rock and concrete. The flame tanks changed that calculus instantly. Suddenly, nowhere was safe. A cave that seemed impregnable could be cleared in seconds by a weapon that could reach 150 yards, penetrate enclosed spaces, and kill through heat and oxygen deprivation even when the flames themselves didn't directly reach the target. The psychological impact on Japanese defenders was significant. Captured documents and prisoner interrogations after the battle revealed that Japanese soldiers feared the flame tanks more than any other American weapon. The reasons were practical. You couldn't hide from them. You couldn't dig deep enough. The flames would find you, or the heat would, or the lack of oxygen would. Traditional courage and determination, qualities the Japanese military cultivated extensively, were useless against an attack that killed you by suffocation before you even saw the enemy. American commanders took notice. The 8 flame tanks at Iwo Jima were working almost continuously, rotating between firing missions, refueling, and maintenance. Each tank was consuming approximately 1,000 gallons of napalm per day. Multiply that by 8 tanks over 36 days of combat, and the total approaches 360,000 gallons. That's not counting the portable flamethrowers, which were also being used extensively. The demand for napalm was so high that in June 1945, the 43rd Chemical Laboratory Company built a specialized production facility in the Pacific Theater that manufactured over 250,000 gallons. By mid-February, even before Iwo Jima was secured, the Marine Corps and Army were placing orders for additional flame tanks. 72 more units were requested for the planned invasion of Japan, Operation Downfall, which was scheduled for November 1945. The urgency was classified as AAA procurement priority, the same designation given to the B-29 bomber program and the atomic bomb project. This wasn't just another weapons system. This was considered war-winning technology. Colonel Unmacht's flame tank group eventually produced 354 total vehicles before the war ended. 70 were ready by victory over Japan Day in August 1945, though they never saw combat because the invasion of Japan was cancelled following the atomic bombings of Hiroshima and Nagasaki and Japan's subsequent surrender. The question that military historians have debated for decades is this: if the invasion of Japan had proceeded, how effective would these flame tanks have been? The projected casualties for Operation Downfall were staggering. Some estimates suggested American forces could suffer 1 million casualties taking the Japanese home islands. Japanese civilian and military deaths were projected even higher, potentially in the millions, given the determination to resist invasion at all costs. The flame tanks would have been critical to that operation. Intelligence indicated that Japan's home defense strategy relied heavily on cave and tunnel fortifications, similar to Iwo Jima, but on a vastly larger scale. Every coastal approach had been prepared with bunkers, pillboxes, and underground positions. Japanese civilians were being trained in militia formations, armed with bamboo spears and basic explosives, prepared to resist an invasion with suicidal determination. The flame tanks, which had proven so effective at neutralizing fortified positions on Iwo Jima, would have been deployed in much larger numbers against these defenses. But the war ended before that happened, and the flame tanks' combat legacy remains tied almost exclusively to their use on Iwo Jima and, to a lesser extent, Okinawa. The technical specifications of the CB-H-1 flamethrower system reveal why it performed so differently from anything that came before. Start with the fuel delivery mechanism. The system used compressed nitrogen stored in cylinders mounted inside the tank's hull at 250 pounds per square inch. That pressure was critical. Lower pressure meant shorter range and dispersed flame patterns that wouldn't penetrate effectively into cave systems. Higher pressure risked bursting fuel lines or causing catastrophic failures in the nozzle assembly. The fuel itself was a carefully calibrated mixture: 65% gasoline, 35% napalm, thickening agent by volume. Too much napalm and the mixture became too viscous to flow properly through the delivery system. Too little, and you lost the adhesive properties that made the weapon effective. The fuel tanks were constructed from quarter-inch steel plate, welded and pressure-tested. 300 gallons sounds like a lot until you understand consumption rates. At full pressure, the flamethrower expelled approximately 5 gallons per second. That meant each tank carried enough fuel for roughly 60 seconds of actual firing time, divided across multiple bursts. The projector assembly, the business end of the system, was the most complex component. Engineers had to solve a problem that sounds simple but required extensive testing. How do you ignite a stream of liquid fuel as it exits a nozzle traveling at high velocity? The solution was a spark plug ignition system positioned just inside the nozzle mouth, firing continuously at 30 sparks per second while the trigger was depressed. The timing had to be precise. Ignite too early, and you'd get combustion inside the nozzle, potentially destroying the weapon and killing the crew. Ignite too late and you'd spray unlit napalm, which would then either fail to ignite or create unpredictable fire patterns. Range varied based on multiple factors. At maximum pressure with optimal fuel mixture and level trajectory, the weapon could reach 150 yards. But that was under ideal conditions. Firing. Uphill reduced range by approximately 20% because you were fighting gravity. Wind affected the flame stream significantly. A 15-mile-per-hour crosswind could push the flame jet off target by 10 to 15 feet at maximum range. Temperature mattered too. The napalm mixture performed best between 60 and 90 degrees Fahrenheit. In the tropical heat of the Pacific Islands, viscosity decreased slightly, giving marginally better range but less adhesion when the flames hit their target. The crew training manual, distributed in late January 1945, emphasized specific engagement protocols. Approach targets at oblique angles to minimize exposure to anti-tank fire. Stop the tank at least 100 yards from the objective. Fire in 3 to 5 second bursts, rather than sustained streams to conserve fuel and prevent nozzle overheating. Wait 2 to 3 seconds between bursts to allow the ignition system to cool. Never fire at targets closer than 50 yards, because the backwash of heat and flame could damage the tank's external equipment or injure infantry operating nearby. The manual also detailed maintenance requirements that were extensive and unforgiving. After every firing mission, the crew had to flush the fuel delivery system with clean gasoline to prevent napalm residue from clogging the lines. The ignition system required inspection and cleaning after every 20 bursts. Nitrogen cylinders needed replacement after approximately 30 bursts, or whenever pressure dropped below 200 pounds per square inch. Fuel tank seals had to be checked daily because even minor leaks could create fire hazards. Combat operations on Iwo Jima revealed problems the training in Hawaii hadn't anticipated. The volcanic sand was impossibly fine and got into everything. Crews reported that sand infiltration into the fuel system caused frequent clogs that required field disassembly and cleaning. The island's terrain was more extreme than expected. Slopes of 30 to 40 degrees were common, and firing uphill at those angles reduced effective range to barely 90 yards. Japanese defensive positions were often built into terrain features that made direct line-of-sight engagement impossible, without exposing the tank to anti-tank fire from multiple directions. The solution required combined arms tactics that evolved through trial and error during the first week of combat. Infantry would advance and identify cave positions, then pull back while artillery and tank guns suppressed visible enemy positions. The flame tank would advance under covering fire, usually accompanied by at least 2 standard Sherman tanks for protection. The flame tank would engage the target, then immediately reverse to a covered position while the supporting Shermans provided suppressive fire. Infantry would then advance to confirm the cave was cleared or call for additional flame strikes if resistance continued. This doctrine produced results, but at a cost. The 8 flame tanks on Iwo Jima operated in a combat environment where Japanese anti-tank capabilities were limited but not absent. The Japanese had Type 1 47mm anti-tank guns, magnetic mines, and suicide teams armed with satchel charges. They specifically targeted flame tanks when they could identify them, understanding that eliminating these weapons would restore the defensive advantage their underground fortifications provided. The tank commanded by Sergeant Robert McIntyre on March 1, 1945, provides a case study in these risks. McIntyre's tank, nicknamed Genie, was advancing in support of 1st Battalion 28th Marines during the assault on Hill 362. The flame tank Torch accompanied his platoon. McIntyre spotted a cave entrance with visible Japanese soldiers and maneuvered his standard gun tank to engage. What he didn't see was the concealed machine gun emplacement dug into the ground directly ahead. When his tank drove over it, the roof collapsed and the 30-ton Sherman dropped into the position, becoming immobilized with its bow pointing skyward at a 45-degree angle. Japanese troops immediately concentrated fire on the trapped tank. McIntyre's crew bailed out under fire, running toward friendly positions while Marines provided covering fire. The flame tank Torch moved forward to cover the extraction. According to the tank commander's after-action report, Japanese soldiers emerged from a nearby shell hole, attempting to reach the abandoned tank with explosive charges. Torch's operator engaged them with the flamethrower at approximately 70 yards range. The report stated simply, "The enemy dived into a shell hole, and that is where they met their doom with our flame." The immobilized tank remained stuck for 3 days before engineers could safely recover it, a testament to how contested every yard of Iwo Jima remained, even after areas were nominally secured. This incident illustrated both the flame tank's effectiveness and the dangerous nature of close-range combat, where mechanical failure or terrain could leave even armored vehicles catastrophically vulnerable. By the second week of combat, Marine commanders had refined their tactical employment of flame tanks based on hard-won experience. The weapons were most effective when used in the morning hours. The reason was practical, not tactical. Morning temperatures were cooler, which meant the napalm mixture maintained optimal viscosity, and the nitrogen pressure systems operated at peak efficiency. Firing during midday heat caused pressure fluctuations that reduced effective range by 10 to 15 yards. Target selection also evolved. Initial doctrine assumed flame tanks would primarily engage large cave complexes and bunkers. Combat revealed that smaller positions, individual spider holes and concealed fighting positions occupied by 2 or 3 soldiers, also required flame engagement because conventional weapons couldn't neutralize them without extensive infantry casualties. The flame tanks found themselves supporting every level of combat operations, from company-level assaults to squad-level firefights. The effectiveness metrics compiled from Iwo Jima after-action reports are striking. Of the estimated 3,000 Japanese casualties directly attributed to flamethrower weapons, both portable and tank-mounted, approximately 30% occurred in the first 10 days of combat when the flame tanks were proving their capability. Marine unit commanders reported that objectives expected to require 2 to 3 days of sustained assault were often cleared in 3 to 4 hours once flame tank support became available. Captain Frank Caldwell, commanding a rifle company in the 26th Marines, stated in his after-action report, "In my view, it was the flame tank more than any other supporting arm that won this battle." That assessment, while perhaps overstated given the combined nature of the assault, reflects the tactical reality that conventional weapons had proven inadequate against Japanese cave defenses. The flame tanks provided a capability that didn't exist through any other means. The Japanese response to this weapon evolved as the battle progressed. Initially, defenders would retreat deeper into cave systems when flame attacks began, assuming they could wait out the assault. This tactic proved fatal when they discovered the flames penetrated much deeper than expected, and the oxygen depletion extended through tunnel networks, killing soldiers hundreds of feet from the actual flame impact point. Later in the battle, Japanese troops attempted more aggressive countermeasures. Suicide teams, armed with magnetic anti-tank mines and satchel charges, tried to close with flame tanks during engagement, betting they could reach the vehicle before the crew could react. These attacks occasionally succeeded. Marine reports document at least 3 instances where Japanese soldiers managed to damage or destroy flame tanks through close-range attacks, though in each case supporting infantry and accompanying gun tanks killed the attackers. The most effective Japanese defense proved to be simply staying deeper underground in positions with sufficient ventilation that the oxygen depletion effects couldn't reach them. Some of the larger tunnel complexes on Iwo Jima had been engineered with multiple air shafts and ventilation systems, sophisticated enough that a flame attack on one entrance wouldn't affect defenders in other sections. These positions required either systematic cave-by-cave clearing operations or the eventual tactic of sealing entrances with explosive charges and literally burying the defenders alive. The battle reached its climax in early March, when Marine forces assaulted the northern sectors of the island, where Japanese defences were most concentrated. The terrain there featured rocky ridges and draws that created natural strong points. Japanese engineers had enhanced these positions with concrete fortifications and interlocking fields of fire that made conventional assault suicidal. The flame tanks operated almost continuously during this phase, sometimes firing 20 to 30 missions per day per vehicle. Maintenance crews worked through the night to keep the tanks operational. Refueling alone required approximately 45 minutes per tank. 300 gallons of napalm mixture had to be hand-pumped into the fuel tanks through filtered lines to prevent contamination. Nitrogen cylinders had to be replaced, ignition systems cleaned and tested, and the entire fuel delivery system inspected for leaks or damage. The crews existed in a perpetual cycle of combat operations, maintenance, sleep deprivation, and more combat. One incident from March 8th captures the intensity of these operations. A Marine battalion was pinned down by fire from a complex of caves and pillboxes on a ridge, designated Hill 362B. Standard doctrine called for artillery preparation, followed by infantry assault supported by tanks. The artillery barrage had minimal effect because the positions were too well protected. 2 flame tanks, accompanied by 4 gun tanks and a platoon of infantry, advanced on the position at approximately 1400 hours. The lead flame tank engaged the first cave entrance at 110 yards, expending approximately 30 gallons in a sustained burst. Japanese fire from adjacent positions immediately increased, machine guns and rifles concentrating on the flame tank. The tank commander reported later that at least 15 rounds struck his tank's armor during the engagement, none penetrating but several leaving significant impact craters. The second flame tank engaged a pillbox while the gun tanks provided suppressive fire. The assault lasted 17 minutes. When it concluded, Marines advancing into the position found 43 Japanese soldiers dead, most from suffocation or burns. The battalion was able to advance another 200 yards before encountering the next defensive line. Without the flame tanks, taking that ridge might have required days and cost dozens of American casualties. The final organized Japanese resistance on Iwo Jima ended on March 26, 1945, 36 days after the initial landing. The island was declared secure, though isolated groups of Japanese soldiers continued to hide in the tunnel systems for months afterward. The 8th Army's 147th Infantry Regiment spent the next 3 months conducting cave-clearing operations, killing an additional 1,600 Japanese troops who refused to surrender. The flame tanks had performed beyond expectations, but at significant cost to their crews. Combat stress among flame tank operators was notably high. The nature of their weapon, the psychological weight of using fire as a tool of war, affected crews in ways that commanders hadn't anticipated. Some men requested transfers out of flame tank units, citing nightmares and psychological distress. The military didn't have formal combat stress protocols in 1945, but unit commanders recognized the issue and rotated personnel when possible. The technological legacy of the CBH-1 flamethrower system extended beyond World War II. When the Korean War began in June 1950, American forces found themselves again facing entrenched defenders in terrain that favored defense. The M4A3R3 flame tanks, officially designated as POACWSH-5 in their updated Korean War configuration, saw extensive use in the first year of combat. They were particularly effective during the defense of the Pusan perimeter and the subsequent United Nations counteroffensive, where North Korean troops had fortified positions in hills and ridges. The lessons learned from Iwo Jima informed the development of subsequent flame tank designs. The M67 flame tank, introduced in 1955 and used extensively in Vietnam, incorporated improvements in fuel capacity, range, and reliability directly descended from the World War II systems. The M67 could carry 400 gallons of fuel and had a maximum range approaching 200 yards, but the fundamental operating principles remained identical to what the Seabees had built in Hawaii a decade earlier. The ethical questions surrounding flamethrower weapons became more prominent in the decades after World War II. The 1980 Convention on Certain Conventional Weapons restricted the use of incendiary weapons against civilian populations, though military applications remained legal under international law. The United States removed flamethrower weapons from active service in 1978, driven partly by changing military doctrine and partly by growing concerns about the humanitarian implications of such weapons. But on Iwo Jima in February and March of 1945, those ethical considerations were distant abstractions. The immediate reality was simpler and more brutal. American forces needed to neutralize Japanese defenses that conventional weapons couldn't touch. The flame tanks provided that capability. Marines who fought on that island, who watched friends die trying to clear caves with portable flamethrowers and satchel charges, had no ambivalence about the weapon's value. It saved American lives by taking Japanese lives more efficiently than any alternative available. The final assessment of the flame tank's effectiveness comes from Japanese sources. Documents recovered after the battle, including portions of Lieutenant General Kuribayashi's war diary, reference the flame tanks specifically. One entry from late February describes them as the one weapon that caused our soldiers to abandon their positions and attempt escape. This from a commander whose entire defensive strategy relied on troops staying in their fortified positions regardless of the assault they faced. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.